These are the notes to section 5.6, the triangle inequality. The objective is I will be able to apply the triangle inequality theorem. The triangle inequality theorem says the sum of the lengths of two sides of a triangle is greater than the length of the third side. So what that means is that I can take any two sides on the triangle. When I add them up, they're going to be greater than the third side. So if I take sides AB and AC, the triangle inequality says this is going to be strictly greater than the remaining side, BC. Another two sides would be AB and BC. That has to be greater than the remaining side, AC. And lastly, AC plus BC has to be greater than AB. So whenever we get into some examples, this is actually a lot simpler than all this notation may make it seem to be. We need to determine whether the given measure can be the lengths of the sides of a triangle. So what we're going to do is we're going to add the two smallest sides. We're going to do 1 and 3 together. So number 1, actually let's do 2 and 3 together. Do 1 on your own. So number 2, the two small sides are 6 and 12. Is 6 plus 12 greater than the remaining side, 18? So we have 18 is greater than 18. This is no. Therefore, we answer the question, determine whether the given measures can be the length of the sides of a triangle. Well, no. It has to be strictly greater than the third side. So again, we're going to add the two smallest for number 3, 5.1 and 6.8. We're asking, is it greater than the remaining side, 7.2? And if we add it, we get 11.9, which is greater than 7.2. So yes, this can be the sides of a triangle. I want you to try number 1. We also are told to find the range. You should remember the range is your lowest possible value and your highest possible value. So find the range for the measure of the third side of a triangle given the measures of the two sides. So all we do here is subtract and add. So let's subtract. We're going to have 12 minus 7 is less than x, which is less than adding it, 7 plus 12. So all we end up with is 5 is less than x, which is less than 19. All this means is that in order for this to be a triangle, I need something greater than 5. So it could be 6, 7, 8. It could also be 5.01. That would make a triangle. And it has to be less than 19. So 18.9, 18.999, 17, 12. Those are all numbers that would work. We'll do number 6 also, 17 and 12. So again, we subtract 17 minus 12 is less than x, and then we add. So our values have to be between 5 and 29. I want you to try number 5. The last problem is much easier with a calculator. It says determine whether the given coordinates are the vertices of a triangle. So you should remember the vertices are the endpoints of a triangle. In order to do this, you need to use the distance formula. So we've been using the distance formula throughout the year. I'm going to write it down again. It's where we subtract the x values and square it. And we subtract the y values and square it. So we add those two values up and take the square root. So I'm first going to figure out the length of segment AB. In order to find the length of segment AB, I'm going to use those 2 points. My first point is going to be my x1, y1, and my second point is going to be x2, y2. So all I do is take the square root of 5 minus 2 squared plus 8 minus negative 4 squared. Had a lot of practice doing this. We get a number that's very long, so I'm going to approximate. It's about 12.4. If I run into problems where I might have a value that looks like it could be the same, then I'll get a more accurate value. For this problem, that's not going to happen. I also want to find length BC. So to find length BC, I use the distance formula again. 2 minus negative 3 squared plus negative 4 minus negative 1 squared. And I get 5.8. And lastly, I have AC. So again, A is going to be my first point, C is going to be my second point. It's going to be 5 minus negative 3 squared plus 8 minus negative 1 squared. This is about 12.0. So now I have 3 lengths. This is almost exactly the same as this problem here. Could that make a triangle? We have to add the 2 smallest sides. The 2 smallest sides are 5.8 and 12.0. So does 5.8 plus 12.0, is that greater than 12.4? The answer is yes. So these coordinates could make up the lengths of a triangle.